Okie dokie. Did it start? Yeah. All right, so we're going to start here. Yeah. This is going on page 63, I think, yes. 63 when we're done. Let me zoom back out a little bit. Okay, so on here at the top, you have two 30, 60, 90 triangles, right? We talked about special right triangles a little bit last week when we were making some trig ratios. So we're just going to relabel what a 30, 60, 90 triangle looks like. This short leg would be S. Hypotenuse is 2S. And the long leg is S times the square root of 3. Okay? When we did these last week, we made S equal 1, so our numbers were just easy to use. Totally fine. We can make S be anything. But what we want today is we actually want the hypotenuse to be 1. So if the hypotenuse is 1, what would S have to be? 1/2. And what would it make the other leg? 1/2 times the square root of 3, yes, which we'll write as square root of 3 over 2. Okay? And if you look at your 30, 60, 90 triangles that you have, they already have those labels on there for you. Now I want you to grab your two green triangles and put them together like this, just like it is on this paper right here. This is called Triangles for Dummies right now, so we can all get them labeled correctly, okay? So just like this, and in here we're going to put Roman numeral 1, Roman numeral 2, and then you're going to do the same thing in the green triangles as long as they're arranged the same as what's on the paper. Roman numeral 1, Roman numeral 2. This is like why there's directions on the back of the shampoo bottle, so I don't lose my mind when everybody has everything labeled wrong. And you can also add the right angles because I don't have these on these triangles. Okay, we all good with that? And then you can take those triangles and slide them out the way. Grab your two yellow ones. Set them up so they look like what's on the paper. And once again, Roman numeral 1, Roman numeral 2. Do the same thing on the yellow triangles and put your right angles in there. Okay, everybody good? Slide them out the way. And let's talk about our 45, 45, 90 triangles. We label those, that would be S, S, and S times the square root of 2. And again, we want the hypotenuse to be 1, which means that if S times the square root of 2 equals 1, I get to get S, I got to divide by the square root of 2. What's 1 over the square root of 2? Square root of 2 over 2. Remember how we did that? Oops, I can't even write. There should be a 2. Can't talk. That's a 2 on the bottom there. Square root of 2 over 2. Okay. Then you're going to take your two pink triangles, line them up just like it is on the paper. Roman numeral 1, Roman numeral 2. Same thing on the triangles. Right angle. Nothing, it's okay. Nobody's perfect. Did you label them wrong? It's okay as long as you fix it. All right. Are we all good now? And you can slide these out the way now. And flip this over. Okay. So what you have in front of you is a circle. And it's got radian measures on there. It also has degrees, even though I keep telling you we're done with degrees. I just left them on here. But I don't care one single bit if you know that 300 degrees is 5 pi thirds. Not worth the unless you just have the kind of brain that just looks at stuff and just knows it. If you need to know that, you can convert it, but that's not worth trying to waste brain cells for, okay? But this is a circle, but we are going to use it as a unit circle. A unit circle is a circle that has a radius of 1. Okay, and there's lots of beautiful math and patterns and so much stuff going on in this unit circle. We're going to build one today, and we are going to look at maybe one tiny little pattern, but we're not going to have a time to get into kind of everything. We're just going to kind of make it, and I will get to the point of like, why do we even care? Like, what's the purpose of all of this stuff? So to start with that, we are going to take your Roman numeral 1 green triangle, okay, and Roman numeral 1 for quadrant 1, and you're going to set it down right here with that 30 degrees at the origin. This bottom side lined up on the axis, and that should make that other vertex hit that point right there, okay? Then you're going to take one of your pieces of tape and tape it down right there on the axis. When we reflect it, look what happens when I reflect it. You see how it's all wonky? We don't want it to be wonky. So you're going to reflect it, and then you're going to fix it down here so it hits that point and everything's all lined up nice and pretty and it's straight. And then you're going to take another piece of tape, oops, and tape it on the back there. That way, when you reflect it back and forth, it won't get all wiggly. Okay? Everybody with me on that? Okay. So do you see this 30 degrees right here? And that's what this line says right here, because this point rotated 30 degrees, and 30 degrees is pi 6, right? So right here next to this 30, we're going to write pi 6. I left the 30, 60, 90 on there because that's how we talk about special right triangles. But now that we're putting it in the coordinate plane, we need radians. Okay. Now, when this point rotates around to pi 6, I have an ordered pair here. You should be able to tell me what the x value is of that. It is staring you in the face. That's an angle measure. What would the coordinates be? What would the x coordinate be? Think about how you plot points. This one right here. Ooh, you're on the right track, but it's not 1/2. No pi's. Pi's are radian measures. Square root of 3 over 2. What's the y value? 1/2. Where are those numbers coming from? The sky? The sides. If I start here at the origin, to get to that point, I have to go to the right this far and then up that far, right? So when I go to the right, that's my x value. When I go up, that's my y value. Does that make sense to you? So that's where that ordered pair came from, straight from my special right triangle. Okay, everybody with me so far? Okay, so then we're going to reflect this down. What quadrant is our triangle in now? 4th. It's okay. We're in the 4th quadrant. This is still pi 6. This is 1. This is 1/2. This is square root of 3 over 2. Even though you can't really read it because of the glare, but there we go. Okay, so what is this x value? Would the x value be negative? No. The y would be negative, but what's my x value? Square root of 3 over 2. And then my y value would be negative 1/2, right? Because that's the quadrant that I'm in. You'll see that? Okay. Any questions at this point? All right. Now, if I was like a magician or maybe just more creative to come up with something, we would only need one triangle to do what we're doing. I'm going to reflect this back up. What I would like to do is take this triangle and reflect it over into the 2nd quadrant, but it's only held on by that point. So instead, that's why we have a 2nd green triangle. You technically only need 1, but we need 2 because, you know, it's on paper. So we're going to do the same thing, line it up all nice and pretty. It should be pretty darn close to that point. I did cut all these out myself, so if they're a little not perfect, sorry, did the best I could. I just didn't want to wait for y'all to get everything cut out. And then reflect it down and put that 2nd piece of tape on it so that it'll be sturdy for you. And again, that 30 is pi 6. What is the x coordinate? Negative. Good. Square root of 3 over 2. Y coordinate is 1/2. All right, when I reflect this down, what quadrant am I in? 3. Okay, so third quadrant, right angle. This is pi 6, 1, 1/2, and square root of 3 over 2. So now that we're in the third quadrant, just like we've known for a long, long time, x value and y value are both negative, right? So that's where we get negative square root of 3 over 2, negative 1/2. Now I want you to look at the angles that we hit with these. So this one we knew was pi 6. This one right here in the second quadrant, that's 5 pi 6. Down here, that's 7 pi 6. Over here, that's 11 pi 6. There are 4 pi 6 angles in one rotation of the unit circle. That hits all 4 of them. Notice that all of the values, if we're just talking about the absolute value of the coordinates, they're all the exact same numbers. It's just, is it positive or negative depending on what quadrant we're in? That makes sense to you? Also, all 4 of those are the ones that are closest to the x-axis. Now, on your table, there's some highlighters. I only had like 1 or 2 to put on each table, but I want you to grab a green one. And because we used a green triangle, I want you to highlight these numbers green and then pass it to somebody else at your table that needs it. That's all you got to do, is just that. And I wasn't thinking when I did the bright blue paper, I probably should have done a lighter color, but we're just going to do the best we can. All right, we're going to reflect them both back up like this. Then I want you to grab your Roman numeral 1 pink triangle, and you're going to lay it down right on top of the green one. Just like that. And it should meet the next point. And then you're going to put a piece of tape. Just right there at the axis. Then you're going to reflect it down, kind of push it up against the green one and straighten it so it hits the point. And then when you put this piece of tape on it, you're really just taping it to the green triangle, but it'll all work out just fine. Okay. So right here, we put a piece of tape, reflect it down, straighten it, tape it to the green one. Yes. All right, so when this triangle is up here, what is my x value? Square root of 2 over 2. What is my y value? Square root of 2 over 2. This is an isosceles right triangle. That x value and y value are exactly the same because the 2 side lengths are the same. And this is a 45-degree angle. In radians, that is what? It's right there on your paper. It's pi fourths. It's on your paper. You can cheat right now. Okay. We good so far? All right. When I reflect this down, what quadrant am I in? Fourth. So fourth quadrant, right angle. This again was pi fourths. Hypotenuse is 1. Side length square root of 2 over 2. Square root of 2 over 2. Is my x value positive or negative? Positive. Square root of 2 over 2. What about my y value? Negative. Negative square root of 2 over 2. Okay. Any questions at this point? Okay, make sure your second quadrant green one is flipped up. Take your second quadrant pink one. Put it down there. And you're going to tape it. Reflect it down, straighten it up, tape it again. You can get more tape if you need to. It's fine. Just thought it would be easier if we weren't all fighting for the tape dispenser the whole time. All right, 45, again in radians, is pi fourths, right? Okay, is my x value here positive or negative? Negative, so that's negative square root of 2 over 2. Y value is positive square root of 2 over 2. When I reflect this down, what quadrant are we in? Third. Right angle. This is 1. This is pi fourths. Square root of 2 over 2. Square root of 2 over 2. In the third quadrant, x and y are both negative, right? So we got negative square root of 2 over 2, negative square root of 2 over 2. Pi fourths, since it's 45, that means we've rotated halfway through each quadrant. And you've got your 4 pi fourths angles. We got pi fourths, 3 pi fourths right here, 5 pi fourths, and 7 pi fourths. And so all 4 of them are halfway through the quadrants. So your pi sixths is closest to the x-axis. Pi fourths is right in the middle. And just like Nunu predicted, grab your pink highlighter, highlight these pink. Yeah, sorry, it's because of the blue paper. Whatever. The yellow is really going to be disappointing, so. All right, everybody with me? Any questions at this point? All right, flip everything back up. Yep, and you're going to take your Roman numeral 1, yellow one, and tape it right on top like that. Just like everything else. And then reflect it down, tape it again. Okay. All right. 60 is what in radians? Pi over 3. All righty. So then what is this x value? 1/2. Y value, square root of 3 over 2. Right? When we reflect this down, what quadrant are we in? Fourth. This is pi thirds. This is 1/2. 1 square root of 3 over 2. Okay, and I think that you can do that last triangle without me. I bet you can. I want you to try. Pi over, where, what? Okay. Mm-hmm. Well, it should be pretty close. I mean, it's okay if it's not perfect. Yeah. And once you get that done, and you can check yourself with your neighbor, y'all can talk about it. Make sure what you're writing down makes sense to you. And then you can highlight these yellow, even though it probably won't look yellow. Oop, I didn't write this one down. It looks yellow on mine, but it's probably not going to look yellow on yours. Yeah, my paper's white. Because if I do use the colored paper up here, you just really can't see. I should have given y'all all white paper, but I didn't, so deal with it. I don't know what to tell you at this point. So notice that all the pi thirds angles, those are all the ones closest to the y-axis. Pi 6 closest to the x-axis. Pi fourths right in the middle of each quadrant. Okay. Where? On which one? Well, you get it from your triangle. It's whatever it says on the triangle if you can't read my handwriting. It's okay. Yeah, I know. Whatever. Oh, we're getting to it. Give everybody a chance to finish this up. Okay.
Oh my God, that's a lot.
Oh no, it's smeared my blood.
I know. I'm waiting for y'all to get, I'm waiting for everybody to finish writing. Some people are still writing and highlighting.
Right, 1/2, 3/2. No, 1 here.
Okay, so let's talk. What do we think the x value is right here? What would make sense? Whoops, sorry.
2.
Right here.
Wait,
1. Why? Because it's the radius. Very good. See how the hypotenuse of each one of these is 1? That is the radius of the circle, right? And the radius is the same all the way around, plus it's a unit circle. That's a 1. What's the y value? 0. Very good. So what's this one? What's this order pair?
2,
0, 1. What would this one be? Where are you getting 2 from? -1, 0. And this one would be 2. No, 0, -1. There's no 2. Stop saying 2. 1, 0. Those 4 that we just wrote are the easiest ones, but for some reason, it's the ones that are the most difficult for people to remember and figure out. So, all right. Do we all have this all labeled? Yes. Okay. You're going to the top left of, actually, before we do that, come over here on to the right of this green triangle, like have your green triangle flipped up and draw along the edge. So you're basically drawing a little line segment so you can flip it down and have a triangle there that you drew. Does that make sense to you? I just,
So I do that for all of them?
no, just this one, just this one.
Oh, well, yeah, it actually do perfect.
Okay, so this is theta. The angles that we care about are at the origin. We don't care about these over here, okay, because we're not really going to be looking at these as triangles most of the time anyway. But this is the angle that I care about. For this particular triangle, it is pi 6, but we're just going to pretend like this is just a generic right triangle and not really worry about the fact that it's literally pi 6 right now, okay? So pause on that thought for just a second. Go to the top left of your paper, and let's talk about some trig stuff and figure out why we're even talking about this. So if I have sine of theta, from SOHCAHTOA, what is sine of theta? Opposite over hypotenuse. Okay, we all agree with that, right? That's old business. Now I'm going to go back and look at this triangle. Here's my theta. This is the opposite side of my triangle. What that we did represents this side of the triangle. The y, right? Because that's the 1/2, right? So this, your opposite for any of these triangles would be the y value. Does that make sense to you? And the hypotenuse I know is 1, but it's not always 1. It's 1 in a unit circle. What part of the circle is this? Radius. So instead of opposite over hypotenuse, it's really the y value over the radius. Does that make sense to you when you put it on the circle? So opposite over hypotenuse in the circle becomes y over r. But since this specific one is a unit circle, we can make that y over 1. Which means in the end, sine theta is equal to y. And that's huge. Because if we look back over here, and I ask you for the sine of pi 6, the sine of pi 6 is 1/2. The sine of pi 4 is square root of 2 over 2. The sine of pi 3 is square root of 3 over 2. Does that make sense? That's what this is because of all of this stuff that all starts to come together. Okay? Now let's go to the, or actually let's write this. So that means my y value here, this is sine theta. All right, bottom left. Cosine theta from SOHCAHTOA is what over what? Adjacent over hypotenuse. Okay. So when I come back and look at this triangle that I have right here, this is my theta, that's the opposite, so this is the adjacent, this is my x value, right? Adjacent over hypotenuse becomes x over r. So this is x over r. But again, in this specific triangle, since we have a unit circle, this is x over 1, and cosine theta is equal to x. So every ordered pair we just wrote down gives us our sine and cosine values for all of those special angles that we need. Not only that, but if you notice that, remember, look at all my yellow ones, right? They all have the same numbers. All that changes is whether it's positive or negative depending on the quadrant. So if I ask you for the cosine of pi thirds, it's 1/2. If I ask you for the cosine of 2 pi thirds, the first thing you're going to think is cosine of pi thirds is 1/2. I'm in the second quadrant, so it's a negative 1/2. Do you see how that works? So you're not really memorizing all of these values. I'm going to give you ways to kind of step it through your head, which it will be a piece of cake. On top of that, if I asked you for the cosine of 34 pi thirds, right? You know it's 1/2 or negative 1/2. You would just have to figure out which quadrant you're in so that you could give the right value. You with me on that? So you know an infinite amount of answers if we can figure out the quadrants. Everybody good so far? So bottom right, let's write this. Anytime you have an ordered pair and we're dealing with a unit circle, it is always cosine theta, sine theta. Those of you in AP Physics, you know your mg cosine theta, mg sine theta. That's kind of what we're getting into here with this. That's your x and y values there. You haven't done that yet? I thought y'all did that at the beginning. They might have mixed it around some. All right, we all good so far? Let's talk about tangent a little bit. Top right. So tangent theta from SOHCAHTOA is what? Opposite over adjacent. Okay, and we already figured out that the opposite was y and the adjacent was x, right? We also know that y is sine and cosine is x. Sorry. So that means that tangent theta could also be sine theta over cosine theta. So if I want the tangent of pi fourths, I can put the square root of 2 over 2 over the square root of 2 over 2. Those cancel out and give you 1. If I make fractions out of these, I'd have to rationalize a little bit, but I'm going to give you a different way to know them anyway, so you're not doing that math every single time. But you do need to know that it's sine over cosine. Okay, we good so far? All right, so down here, I forgot to write that this is cosine theta, so let's do that. Your x value there, that's your cosine theta, sine theta. All right, so now you're going to take your ID to use as a straight edge, and you're going to draw a line, and you're going to make it as parallel to this purple line that I have here as possible. It's okay, it's not perfect. And you're going to draw right through some of the numbers you wrote, and that's okay too. Just need to draw that in. And if you drew right through some numbers you wrote, it's totally fine. Because you're also going to take this radius and you're going to extend it to there too. And if you're right on top of a number, it'll be fine. So you drew this blue line, well, mine is blue. This blue line, you just extend to this radius here so it touches it. Okay. Maybe. All right, and then we're going to label this point up here A and this point down here B. Yeah. So do you see how I have a white triangle that has a purple side right here, and then I have a bigger white triangle that has a blue side, and they're overlapping? You'll see that I got this triangle here and this triangle here. So they're like overlapping triangles. All right, so since they're overlapping like this, they are similar by angle, angle. Okay, another little throwback to geometry. All that stuff means something. So since they are similar, I can write out a little proportion. So I'm going to put sine theta over cosine theta. So sine theta over cosine theta. If I'm going to do a proportion, I've been doing proportions forever. If I'm going to put this side over this side, then in the big triangle, this side has to go on top. That's why we had to label it AB, so we can call it line segment AB. It would be this side over this side. What's the length of this side here? 1. So AB over 1 because it's the radius. Does that make sense? Sine over cosine, AB over 1. It's just a proportional relationship. But we also know that sine over cosine is tangent. So tangent theta really just equals the length of AB. So this line segment right here, that length right there, that is the tangent value for that angle. That's tangent theta. And that is why tangent is called tangent. So if you recall back in geometry, you learned trig. You might have done trig last. Sine, I don't know what order they do it anymore. But so you learn sine, cosine, and tangent, and then you learn circles, or maybe it's vice versa. But then with the circles, you talk about tangent lines, and you're like, what does that have to do with trig? And in your mind and in geometry, it has absolutely nothing to do with trig. But the truth is it has everything to do with trig, because you see how this line is tangent to this circle? That tangent line right there gives you that tangent value. That's why the tangent line is called a tangent line. That's why it's named that way. Okay, does that make sense? Now, I'm just showing you that to show you that, to show you how things connect. That's not something, we're not going to actually draw a tangent and figure it out that way when we do it, but everything else we talked about today is important. Okay, now y'all are getting fidgety. Shh. All right, so in your assignment today in Delta Math, I highly encourage you to get it done today. It won't take you that long. And it's going to ask you, like, what is the sine of 7 pi 6? I don't expect you to know that right now. I want you to use your unit circle. I want you to everybody find 7 pi 6. And the sine is -1/2, right? And so in Delta Math, it'll say, what is the sine of 7 pi 6? And then it's going to make you draw that angle. It's going to have a blank circle with a point right here, and you have to rotate it to right here. Now, in Delta Math, as long as you get close to it, it'll snap to it. You don't have to, again, we're not getting out protractors and stuff. Just, I mean, it's going to stop at one of these 3 places. So you draw that, and then you can use this to know that the answer is -1/2, because I want you to understand how to use this and what these values mean. Okay? We okay with that? Any questions on how to use this or what's happening? What is the cosine of pi halves? 90. Well, that's the angle measure in degrees. What's the cosine of pi halves? 0, because it's just the x value right there. Okay. The other thing is just look at, kind of stand your triangles up and look at the measurements. So like when we're talking about, there's 4 pi 4th angles, 4 pi 3rd angles, 4 pi 6th angles. But like, if you look at the degrees, if I asked you about 240, you'd have to figure out which quadrant you're in, which one it is. And if you just know it's 4 pi 3rds, it's a pi 3rds angle, everything makes a whole lot more sense. Instead of talking about 5,280 degrees, it would be something like 57 pi over 2 or something like that, right? And you'd know it's a pi halves angle. I don't know that those numbers, no way they're right because I just made them up. But do you see how the patterns work way better with radians? Okay, and I'm going to continue to make you believers on that. Don't lose this. When you tape this in your ISN, I would fold it, and then you can tape along the top and the sides and the bottom. Yeah. And don't lose this. We're going to keep coming back to this. We're going to come back to this tomorrow, talk about it some more, look at some other patterns and some other things that are happening, but we just got to get it done. Any questions at all? All right. Let's see if I can pause this video. If I can find my mouse. There we go.